Okay, the fourth technique that we're going to use to solve quadratic equations is called completing the square. Okay. And the method is described here, and we'll, of course, do an example in just a minute. But ultimately, if we have something of the form x squared plus bx plus c, okay, what we can do here is we can add b over 2 squared to both sides of the equation and then factor the left side to the new equation, and then we'll kind of see how it plays out from there. But bottom line is I want you to notice a couple things for the use of this. Number one, notice there's no a here. Okay, so if there's no a here, okay, that means that we can't have something like 2x squared, because then this process wouldn't work. Okay. Now, we can remedy that. We'll see that in a minute, how we can get it to look like this in just a minute. But regardless, what we want to do is always put it in that form first. So put the constant on the right, the x squared term, and the bx term on the left. Okay. And then from there, again, b is just the coefficient on x, whatever that is, divided by 2. That's going to be a number, of course, squared. And we're going to add that to both sides. Okay. And then ultimately what we're going to do is factor the left side. And once we factor the left side, notice what it looks like. It's going to look like this squared equals a number. And that's going to be just like we did yesterday with extracting square roots. And we'll proceed the same way we learned how to yesterday with that. All right. So let's take a look at an example then. We'll take a look at x squared plus 6x minus 9 equals 0. Okay. And if we put it in the form that they asked us for, it would look like that. They said we want it to look like x squared plus bx equals c. Okay. All right, and then from there, what we're going to do is we're going to add b over 2 squared to both sides. So if I look at my b here, that's 6. If I put that over 2, that would make it into a 3. Okay. And if I square that, that would make that into a 9. So ultimately, it would be 6 over 2 all squared. That would be my b squared over 2 in this case, which turns out to be 9. And so what I'm going to do is I'm going to add 9 to both sides. Okay. So I'm going to add that 9 to both sides. Okay. Now, the reason that I add that number, that particular number, it seems kind of a weird number to add, b over 2 all squared. Okay, but what that does for me on the left side is it makes a perfect square trinomial. Okay, which means it factors into a binomial squared. Okay, if we were to do the math on this, it would turn out to be x plus 3 times x plus 3. Okay, and I want you to notice that when you do the factoring of this part, okay, that 3 right there, okay, isn't that really b over 2? Okay, kind of like what they showed you in the definition. Okay, that number is always going to be b over 2. Okay, so once you add that quantity to the left side, it's always going to factor to x plus b over 2. Whatever b over 2 is going to go in this spot. And then from there, you're good to go. Because once we get it factored like that, now, like I said from yesterday, that's an extracting the square roots problem. Okay, we can just say x plus 3 all squared equals 18, square root, square root. Okay. And we get x plus 3 over here. And then with the square root of 18, plus and minus, of course, we have to subtract 3 from both sides. And so far, that would be our answer. And remember, we always want to put the whole number part to the left of the square root when we have the plus and minus situation, especially. Okay. And one more thing that needs to be done here. What's wrong with 18? It can be simplified. 9 goes into it, so we could write it as a 9 and a 2. Make it a 3, radical 2. Final answer for that part. So overall, we'd have negative 3 plus and minus 3 radical 2. Okay. And those would be the two solutions to our quadratic equation. Now, just to illustrate, okay, the fact that we can check this still even though the answer has got radicals in it. Okay, if I were to take my equation and put it in my y equals my x squared plus 6x minus 9, and go to my table, clear those two, and type in negative 3 plus 3 radical 2. I get 0, which is good. True? We want that to be 0 because our claim is that those are the zeros of this function. Those are the numbers that will make the equation equal 0. And you can check the other one also by typing in -3 minus 3 radical 2. And you get 0 for that one too. Okay. If you knew the decimals for these two, could you also use the graphing calculator and do your 0 command and see if the decimals match up as well? Sure. And a reminder on the ACT test, are they going to ask you, oh, you did the quadratic equation there, how'd you do it? Did you complete the square? Did you do it by the graph? Are they going to ask you that question? No. Okay. So keep in mind that on a multiple choice test with the graphing calculator, no good reason to get that problem wrong. True? Got way too many ways to do it. Okay, I want to look at one more dealing with completing the square. And that will be following. It's going to be 3x squared minus 6x minus 7 equals x squared minus 3x minus x times x plus 1 plus 3. Alright, so that's your typical quadratic equation, right? Okay. It's quadratic. You can see that there's only going to be squared terms in there. Even when we distribute here, we're still just going to get an x squared. So clearly this is not even close to being ready to be solved. True. So we got some simplifying to do. The left side looks okay. I'll leave the 7 over here for now, even though we know we're going to move it over in a minute when we do the completing the square. But I want to get this mess fixed up on the right first. So if I do minus x squared minus x plus 3, remember we're distributing a negative x into the parentheses. So make sure we're careful with our signs here. If this is a negative x out in front, it's got to be negative x squared, negative x. Combining like terms, those two would actually cross out. Got an x squared and a negative x squared, so that's convenient. These two would make negative 4x plus 3. And at this point, let's start to get the stuff where we want it. Let's get the x stuff on the left and the constants on the right. So we'll add 4x, and then we'll add 7 at the same time. And if we do that, we wind up with 3x squared minus 2x over here. And over here, we're going to wind up with 10. All right. And again, I set this up for completing the square because I want to try that technique one more time. However, what issue do we have here? Anybody see what's something wrong here? Yeah, that 3 is a problem. We can't have that 3 there either. So what we need to do is make sure that we divide everything by 3, because the process doesn't work unless we have x squared only. Alright, now with that said, the b over 2 all squared this time, we need to figure out what that is. Well, our b this time is negative 2/3. Keep in mind it really doesn't matter whether it's negative or positive because we're squaring the result regardless, so it's going to be positive whatever we get out of this. So if we just go 2/3 divided by 2 and then square that, remember 2/3 divided by 2 is the same as multiply by a half. So 2/3 times a half would be 1/3. Square that, we'd get 1/9. I shouldn't have wrote those unnecessary parentheses. Okay. So 1/9. If we go 2/3 divided by 2, that's 1/3. And if we square that, we get 1/9. And once again, we're going to add that to both sides. So we're adding that strategic number to both sides. And once we do that, then here we're going to have x minus, so we're going to same sign as what the b had here. And remember, we're going to do this with, or what goes here is our b over 2. Remember, b over 2 is 1/3. And the only other thing we're going to do is add these two together. We've got a 3 and a 9 as our denominators. So if we make this into a 9, that would become a 30. 30 over 9 would be the same as 10 over 3. So it would be 31 over 9 overall over here. Keep in mind that if you had a calculator available at this point, could you work these fractions with your calculator if you had to? You can. I would suggest trying not to, though, because the more you practice this without it, the easier it is going to be for you. If you continue to not practice, you'll continue to not get better. True? All right. And then from there, we will square root, get x minus 1/3. And over here, we'd get the square root of 31 over 3. Conveniently, this time we had a perfect square on the bottom, notice. So therefore, the bottom doesn't have a radical. So that's convenient. You don't have to worry about multiplying by radical over radical here in this case. And if we add a third to both sides, we're going to have 1/3 plus and minus radical 31 over 3. And that's it.
What is the line for 119?
I was just pointing out that that's the strategic number that we're adding. So nothing other than the emphasis on it. Good question. Okay, questions on that process? All right, so in general, what is it generally going to take for us to be able to do this well? How did you learn how to solve linear equations the first time? What did you do a lot? Practice. So what's it going to take to be able to do this very well? Practice. Okay, it takes practice to be able to make sure you do everything right, follow the technique correctly, okay, and work with the positives, negatives, fractions, and so on. Okay, but if you do that, okay, you'll get good at it just like you